In the deserts of North America, scorpions thrive. Most scorpions are harmless to humans, but one group of species is an anomaly, producing venom that is far more toxic than that of most other scorpions. Biologists have worked for decades to understand why and how this group of species, collectively known as striped bark scorpions, produces such toxic venom.
Bark scorpions aren't only found in deserts. They're found all the way down to the tropical forests of northern South America. In many of the places where you can find bark scorpions, their sting feels nothing worse than a wasp or a bee. But in one part of northern Mexico and the southern US, bark scorpions have become extraordinarily more toxic. They're capable of killing adult humans.
Like other scorpions, striped bark scorpions have a venom gland in their tail and a stinger that acts like a hypodermic needle to inject venom into potential prey or would-be predators. Unlike closely related species, striped bark scorpions produce toxins that can be lethal to mammals, and their sting is extremely painful.
Their venom doesn't cause any actual tissue damage, it just simply activates your pain pathway to make you think you're being burned or you've had your finger hit with a sledgehammer, and that actually hasn't happened.
They'd been studied for a few decades, but nobody bothered to ask the question why. Why do they have toxins that target only mammals and that can kill them?
Striped bark scorpions don't eat mammals. So biologists Ashley and Matt Rowe hypothesized that the scorpion's mammal-specific toxins must have evolved to combat a mammalian predator.
We both thought, well, one potential predator is the grasshopper mouse.
Grasshopper mice often prey on bark scorpions, and they're no strangers to scorpion venom. So what happens to a tiny mouse when it gets stung by a scorpion that can kill a human? You can see that the mouse experiences pain, but after a few moments, the hunt continues.
The grasshopper mice have actually evolved structural changes to a part of their pain pathway. They literally use a component of the venom to block the signal that the venom is trying to send.
But not all grasshopper mice have this resistance. Both grasshopper mice and striped bark scorpions range widely in North America, and sometimes their ranges overlap. In areas where the two species live together, the mice are highly resistant. But elsewhere, that's not the case.
So if you took a grasshopper mouse from a population where it doesn't coexist with the lethal bark scorpion and it attacked it, and if it got stung, it would die because it would not be resistant to those toxins.
An evolutionary arms race with grasshopper mice may explain why striped bark scorpions have venom that is so toxic to mammals. As the mice evolved to be more resistant, the scorpions evolved to be more toxic. But how have the scorpions evolved new variations of venom quickly enough to keep pace with the resistance of the mice? To find out, evolutionary biologist Lauren Esposito is studying the genetics of scorpion venom.
In order to study venom, what I look at is the genes. To study those genes, what you first need is a scorpion, a living scorpion. And to do that, you have to go out into the environment where they're found and collect them. It's usually pretty hot and sweaty because I'm out in a desert like this or in a tropical forest. And I spend a lot of the day scouting for places that look like good scorpion spots. And a lot of times I turn up nothing during the day. But if I can find a single scorpion during the day and I come back at night with an ultraviolet light, I might find 1,000 scorpions.
Scorpions are nocturnal and fluoresce under ultraviolet light, so with the right equipment, they are easy to spot at night. Lauren collects scorpions and brings them back to her lab to study what scientists call the Venom.
Let's imagine we have a book, and the book is filled with words, and those words make up sentences, and every sentence in the book represents a gene that performs a function in our body. Every time Venom appears in the book, we highlight that sentence. And we were to go back into the book at the end and look at all the highlighted sentences, that would be the Venom, or all of the genes being turned on in the venom gland. Our preliminary evidence from looking at the Venom indicates that the species of bark scorpions with more toxic venom have more copies of the genes that create the toxicity. But the species that are less toxic only have 1 or 2 copies of the same gene. When you only have a single copy of a gene, you only have 1 chance for that gene to adapt. But if you have 10 copies of that gene, then the 10 copies can change in different ways, and maybe one of those ways becomes an effective way to combat your predator.
With so many opportunities for natural selection to act on their Venom, striped bark scorpions have the capacity to evolve more quickly than other species. Their evolutionary arms race with grasshopper mice continues today, with no end in sight. Similar arms races have unfolded since life began on our planet and are responsible for many of the adaptations we observe in life forms across the globe.
Anomalies they're exciting because they're anomalies, right? Because you don't understand them, because there's something weird about them. And it's those anomalies that lead to new discoveries.